Okay, can you see my video now? I mean, my share screen?
Yes.
Okay, okay, very good. Okay, so this week we'll cover probability. Probability-wise, we can go deep or can go easy. I will go medium. Okay. Now the thing is, probability is the soul of statistic in a real sense, and many people don't think that probability is they think too hard. So sometimes statistic is I mean probability may become too an abstract concept to them, but if we know the relationship between frequency and probability, then we will know that probability is just the how do you put it? It's just relative frequency in a real sense. In a real sense, okay. And using the example I mentioned before, if in a class there are 30 students and there are three students that major in biology. So what is the percentage? What's the probability that what's the probability that students will major in a major in probability major in biology in a class? And that is 3/30. 3/30. 3 is a frequency. 3/30 is relative frequency, and 3/30 is 10%. So 10% is a percentage. 10% is also the probability in a real sense. Of course, there is a little bit more stricter definition for probability, but basically that's what probability is in this example. All right, so have this in view, then it will be much easier when we look at the probability. Okay. Here you see I have, I won't go over all these, or maybe just quickly, and not every single item of them, because yeah, we don't need all of them here. Okay, first, probability is a measure of uncertainty. In a real world, we deal with uncertainty a lot, right? Especially like industry like insurance company, and they use very advanced probability. Okay, and one experiment is an outcome that cannot be predicted with certainty. For example, what is like an experiment is just like tossing a coin with the head or tail, you know. And tossing a coin is an experiment, and you can never control its outcome, although it's 50-50, but you will never know. Okay, head or tail. That is an experiment. You toss a die, then you will either get 1, 2, 3, 4, 5, or 6. Okay, you will get one of these 6 numbers with equal probability, but you never know what's the outcome. So this is the probability. Now, sample point is a simple and a simple event, only one outcome. If you if the experiment is to toss a coin, then the sample point include head or tail. If the experiment is to toss a die, then the sample point would be 1 or 2 or 3 or 4 or 5 or 6. 6 simple events. Okay. Then what's the sample space? A collection of all sample points. So for example, if you toss a coin, then the sample space will be, you put a left parenthesis, left braces, left and right braces, and then you put a H, comma, and T, that would be the sample space. And if you toss a die, the sample space will be left braces, left brace, and then 1, 2, 3, 4, 5, 6, right brace. That would be the sample space. Okay. In other words, that's a collection of all your sample points, all your possible outcomes. And if we denote the probability for each sample point with, for example, PH in the subscript, that means the probability for head, and that's 50%. Probability of tail, PT, T in the subscript, and that will be probability of tail. Then each one will be between 0 and 1, and the sum of them must be equal to 1. All right, this is a rule. Anything that doesn't meet this, then something you may have missed some sample point. It has to be the sum of total all the probability have to be 1. In other words, one of the sample point must be the final outcome. Okay, and the probability of any of the sample points happening would be between 0 and 1. Okay. Then an event is any subset of sample space, a specific collection of sample points. So if you toss 2 coins, let's say toss 2 dice, then the event will be the collection of 1, 1, and then parentheses 1, 1, parentheses 1, 2, parentheses 1, 3, or up to parentheses 6, 6. Okay, then an event, if you say the event of all even numbers, then that may be that may include even numbers. So 2, 2, 2, and then parentheses, and then left parentheses 2, 4, and then 2, 6, and then 4, 2, 4, 4, 4, 6, and then 6, 2, 6, 4, 6, 6. So you have what? About 6 out of 36, because 1, 1, 1, 2, 1, 3 to 6, 2, 1, 2, 3, 2, 2, 2, 3 to 2, 6, up to 6, 1, 6, 2 to 6, 6. There are 36 altogether in the sample space. But in this event, you only has 9 sample points. So your probability of that event, which is all even numbers in your outcomes, if you toss 2 dice, that will be 6 over 36, and the probability of that event happening is 1 over 6. Okay, and so up to that point, you have excuse me. Then we have event relationship. We have 2 events that have joined probability. A and B, and AB have intersection. And A and B, this is A or B. And then you have A or A complement. Okay. So with that if we call it the U like union is OR. The intersection with the U inverse is intersection. We call it N. And then A to the power of C is A complement. That means everything other than A. So the result would be A plus A complement. Probability is equal to 1. Probability A equal to 1 minus probability A complement. Okay. For example, in a class, there are 7 male students out of 30 students. Then what's the probability of female students out of 30 students? It must be what? 1 minus 7 over 30, which is 23 over 30 students in a class are female students. Okay. All right. Then I will also, I think I also make, I will make this lecture notes available as well, so you can studied yourself. I will move on to the conditional probability. 1 second. Sorry. Okay, so we have a conditional probability here. Conditional probability is the probability of two events. Given B happened, what is the probability that A also happens? And that would be probability A and B, which is A and B happens and over probability of B. Okay. We will have examples showing this in our homework. Okay. So, for example, in a class, let's look at this. In a class, this is a class. This is a square, rectangle is a class. Let's say B is a probability is a biology major students. Okay, biology, and A, let's say A is chemistry. Okay, in a statistics class, 30 students, 15 are biology major students. 15. Okay, you see where my cursor is moving in B. And then A is what? A is 5 chemistry major students. So you have 10 biology, 5 chemistry, but you have 2 students who major both in biology and chemistry. So how many students major in both? 2. But how many biology major students? 15. So out of how do you calculate the probability given that he's a biology major student B, given B? So you zoom in on B, and then what? Calculate the probability of A and B. Okay. In other words, take the ratio of this shaded area over this B area. Okay, that's what it means. Yeah. So what you should do is actually divide the 2 by 15. 2 by 15, right? 2 by 15. But if you divide 2 over 30 and then over 15 over 30, you will get probability of B in the denominator and probability A and B in the numerator. And that's how you could understand this formula. All right. So this is how this formula works. And then if you multiply PB on both sides, you will get PAB, and then switch the two sides. You'll get PA and B equal to PB times PA given B. All right, that is the case. All right, or you can change the way it's written, switch B and A. Then the probability B given A equal to probability A and B over what? PA. A becomes a place in the denominator. Okay. So in other words, that is what? Join, N is joint probability, equal to what? Marginal, PA is marginal probability, times PB given A is conditional probability. And this formula on the left is also the same. Join equal to marginal times conditional. Okay, so with that, we can move on to what? Bayes rule. And with Bayes rule, we will be able to understand Bayes rule. All right. 1 second. You'll be able to understand Bayes rule. Okay, what does Bayes rule says? That is, for that B1 to BK are events, mutually exclusive events and complementary. What does mutually exclusive? That means there's no joint probability, no intersections among B1, B2 to BK. And there's no union, no no union of all these events. Okay, and so so the law, and here the law of total probability says a probability A is the sum of all their what? All its joint probabilities with probability B. I will show you an example. So it's a little bit complicated looking at the formula. Okay, but PA and BI is what? Is equal to PBI times PA given BI, based on the formula here. Here we saw here, all right? You just put a I to the subscript of B, and then put a sigma, which is summation of all the different joint probabilities on both sides will be it. And so after that, you use the conditional probability again. You will be able to flip the probability around. In other words, what you know was PA given BI, but now after you use the law of total probability, you will be able to calculate PI given A, and that's a formula. One second, it's blocked by this thing. Anyway, okay, let me show you an example, and we will move to the example. Can cover it quickly. For example, this is a jigsaw puzzle. Think of an example of jigsaw puzzle. You will be able to understand this. This is jigsaw puzzle, and with it says divide into what? B1, B2, B3, B4, B5, B6, 7, 8, 9 pieces. But each piece of the puzzles, what? Have no interaction with no overlapping with each other. So their intersection is 0 because there's nothing overlapping, right? No intersection. But when you put every piece of them in their proper position together, they make up the whole thing. That's why the union of all of them is 1. So this is the criteria for Bayes' rule to kick in. Okay, it just when you convert it to a Bayes' rule, it's just like a jigsaw puzzle. All right. So with that, then what? Let's use actually this comment should be up here. It says probability A equal to what? A is what? Apple. Okay, A is apple. Look at this colorful apple. All right. So A is divided among what? B1 to B9. Okay. In other words, A and BI is this part. You see this part. This part. Okay. And A and B8 is this part. This part. And so on and so forth. So in order to get a complete A, you have to what? Put all the joint probabilities of A with B1, B2 to BK together. All right, so with that, and now let's break down to look at B1 and A. B1 and A equal to what? PA given B1 times PBI. You know, you just put the 1 to the subscript of B based on the previous conditional probability formula and multiplicative rule. You will understand, right? And then the same thing for PB and A and so forth. So in other words, this is how you get PA. If you were given PBI, PB2, PBK, and you were given PA given B1, PA given B2, and so forth, you use a multiplicative rule, and then what? You got PA given PA and B1, PA and B2, and PBK and P and A. Then use law of total probability, you will get PA, probability of A. Then in term, but now you want to know what is the probability that given A, what's the probability of BI? Plug in that conditional probability formula again. Only reverse the order because previously, you know, given BI, you have the A. But unless you put all the puzzles, if I show you separately these B1 to B9, you only see this part, but you don't have the complete picture, not until you put all of them together. So that is that's the extra piece of information we know after we put all the pieces together. Before you put all the pieces together, nobody know the colorful thing is an apple shape. But after you put it together, you know it's an apple and you know the size of it. Then you can, based on that new piece of information, you can calculate extra piece of information. And that this kind of rationale is called the Bayes rule. Okay. So with this, now we can go to the come to this assignment. All right. So I will go to the first one and come back to the last one. We can finish everything in time. Okay. All right. The first question is easy because from the statement, you know, for example, recent census found that 52.3% of adults are female. So the probability of female adult is what? 52.3%. And so on and so forth. What is the probability of A and F, which is in the intersection? D is divorce. Okay, so female and divorce obviously is right here. So this is straightforward. And by the way, most of the questions are very doable and not challenging, at least up to this point. Okay, and look, this is a contingency table right here. And what can you do with it? The contingency table provide a cross classification of weights and years for experience for players on a professional team. So look at this, and the contingency table has how many cells? Well, if you you know, you just count it, okay? And including total, that's 4 by what? 4 by 5. Then what's the probability? Okay, if it asks about the frequency, then what's the frequency? What's the frequency that they are under 200 pounds, the weight of the professional players for professional team? Then there are 15 of them. 15 of them. We are talking about frequency. What about rookies? 12 out of 69. 12 are rookies. We're talking about frequency. But if you ask probability, what's the probability that the weight of professional players on the players on professional team is under 200? Then it will be what? 15 over 69. 15 over 69. And another question would be, what is the probability that they are 6 to 10 maybe years experience? 6 to 10 years, it's 18 over 69. So on and so forth. This is how you can use frequency to calculate relative frequency and therefore call it probability. And so this one move a little bit a step further, which is what? Which is to calculate a conditional probability. So the conditional probability is this. As mentioned, look, identify PC1 given R2. So given R2, so that's zooming on the row of R2. How many of them are here? 18. So if we focus on R2, there's only 18. But how many C1 given R2. So you can only find the intersection of C1 and R2 in this second row, so which is, so this is 10. So 10, then what shall you do? 10 over 18 will be the result. And of course, you calculate the it up to use an integer or fraction. Okay, and you know how to do it. All right, so this is, and what if I say PR2 given C1? PR2 given C1. So given C1, you zoom in on the column C1. There's only 13 in C1. And then R2 is 10. So 10 over 13 is PR2 over C1. All right. So I think that's clear. Similar thing would happen, and now everything is converted to probability. Let's go back to the previous one. How do you convert this into probability? Just divide every cell by 30. Then you will get something like this one. Yeah. So not a big deal. And then the same way you calculate that is the same way you calculate this, except this time you take the ratio of probability instead of ratio of frequencies. Not a big deal. For example, given let's say C2 given R2, C2 given R2, still zoom in on this row. What's a C2? So it's 0.23 over 0.52. 0.23 over 0.52. That's it. Not a big deal. Same rationale. Excuse me. And the probability A in this case, A is on. So what is on? On is this column. So what shall you do? You just take the sum of these three numbers. On in the column of on will be the answer, and so on and so forth. This is what do you call PA? Is marginal probability. Marginal probability are those numbers that are what on the, these are marginal, like PC, this the bottom row and the column on the rightist column, they are what? They are the marginal probability. Okay, and so this is how you just sum up them. Okay, will be marginal probability. If it's joined, then you find the intersection of the two row and column will be it. And then okay, then you have the probability, and you will calculate the probability for this question. That will be what? Probably the first species selected is extinct. So extinct, and what? And the probability the first species is selected is extinct is here. These is what? 36.75. 36.75. That will be the its percentage. You see, extinct and yes, but you look at the percentage. Okay, all of them are quite straightforward. Okay, suppose that B1, B2, B3 are mutually exclusive, and complementary. That's what? What does that mean? That means Bayes rule kicks in. Mutually exclusive means nothing overlapping. Complementary means when you take the union of all of them, you get one, the whole thing. Just so B in this six-law puzzle, you have three pieces: B1, B2, B3, and A is the apple. Okay, using this, I've shown you before. The apple is A. So you know how to do this is what? You will multiply B1, PB1 by PA given B1. All right. plus PB2 multiplied by PA given B2 plus PB3 multiplied by PAB3, you will get the PA. Then you divide the product of PB1 and times PA given B1, divide by PA will be the answer. All right, you can use Excel to do it if you like. Okay, it's not that hard. Okay, somewhat like this one. PB, for example, this is another example, but similar. You put PB1, PB2, PB3 in the same column, then PA given B1 under the same column, and then multiply this by that equal to that. You see that? And so forth, and take the sum of this join, you get PA. And then divide this by that to get PB1 given A. So you may refer to this one table, refer to that table will be will be it. Okay. Okay, so for this example, here it says a paper demonstrated the application of Bayes' rule for making inferences about time testosterone abuse among athletes. In a population of 1,000 athletes, suppose 100 are illegally using testosterone, and of the users, suppose 50 would test positive for the testosterone. Of the non-users, suppose 18 are test positive. So you can draw a table of what? The non-user and user in a row. Non-user, user. And then what? Positive and negative. All right. So you have a contingency table. And then make them positive or make them PA or PB, and to calculate the probability. Let me see. This is the last question. So let me. Oh, 1 second. Sorry. I want to take a screenshot, then write down it. Okay, so if you do this, user, non-user, user. Okay, and then positive, negative. Okay, so how many users are there total? Right, non-user 900, user 100, and here's the total. And of the users 50 would test positive, 50 positive, 50 negative, because there's only 100. Of the non-users, 18 test positive. So how many? A2. Okay, so then you can calculate this number, and total. This is 1,000. Okay, so then you can calculate the what? Let's say let's use N, let's use U, and positive and negatives to stand for them. So the probability of N equal to what? You know, probability of on user of user is what, right? Probability of positive, probability of negative, and so forth. And probability given positive, what is the given positive, what is non-user, right? And then probability of given user, given positive, what's the user? So with that, and then you can use the Bayes rule again, right? So just to give you a hint, okay, I think it's good to do just this much, and I will let you refer to my previous slides and use your own learning, okay, to work this out. And you can click on question help as well to work this question out. And I give you many attempts for it as well. Good. This is the last question, and let me see. Let me save it. Save it. This is 8 module 3. The third question. 22, 3. Okay. Assignment week 3. Question 8. Bayes rule. Okay, I may share with you this screenshot. Okay. All right. Good. 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 Let's see if there's any question. Okay. Is there any question, Yvette?
No, and you are gonna post those notes?
Yes, I'll post
Okay.
the files that I used just now, and including this one, to the along with the recording.
Okay, thank you.
Okay.
Thank
All right.
you.
Good. So far so good. No other question.
Nope.
Okay, perfect. Okay, I think it's a good point to stop. Okay, and I will
Okay.
post this hopefully within 2 hours. You have them available, and then you have a whole week to work on these 8 questions. So
Okay.
very, very, very easy. I make your job easier. Okay.
Thank you.
Oh, you're welcome. Okay. And meanwhile, anytime you have any questions, don't hesitate to post the question in the discussion section. All right. Okay.
Will do. Thank you.
Good, good, good. Have a good evening. Okay.
You too.
See you. Bye-bye. Bye. Let me see.